and now we are going to focus on the 5-step methodology, wherein we would get into the detailed part, and then we would try cover the define, as well as we will touch base on the measure phase today. We would have certain exercises to be done today, which would help you to make or prepare the project charter on your own, so that would help you to draft it in a way wherein you get approvals right away. So you're all aware of the define, measure, analyze, improve, and control methodology. So I would not spend any time on it. So now this particular slide focuses on the variation part, because Six Sigma, we not only improve the problem statement that we currently have, it is also important to look at the variation perspective as well, because in my experience, in most of the time, we would improve the problem to an extent what we wanted to cover. So for example, if I'm doing a project on improving the attrition from, so there's an attrition of 15% and I want to reach to 5%. So I've already attained, but I still see there is a lot of variation. Okay. And we all agreed last time that variation is not good for the process. So therefore in Six Sigma, in the analyze phase, I would make you aware of a lot of tests which would help us identify how much variance that we have in this particular area, in this particular X, and so that we can work on it. So for that piece only, we try working on the variation part right from the define phase only, right from the initially, so that we can, if there's any kind of variation, we can look at it. So to make you understand it better, I just want to tell you that there are two types of variation, which we all should be aware of. Though there are many, but for the time being, we'll just focus on the two types. And I think majority of you must have heard, because you have kind of gone through the green belt training, but since we're covering everything from the scratch, I would like to talk about it. So there are two types of variation. One is called a common cause variation, and another is called a special cause variation. Okay, let's understand the difference between common cause and special cause. Common cause is a kind of variation which would always be there in any process or any project or any organization. Likewise, which means that we are expected that this much amount of variation would also be there. And this amount of variation is not very easy to identify. It is very, very difficult to identify, because we don't know why there is a variance, because this is already there in the process. So when you look at any sort of data, you would see, even you look at the volume data, or you look at the number of errors data, if you look at the quality data, if you look at the production data, you would never see the values are constant. Okay, even though there is a dedicated process, there are dedicated number of teams, everybody's trained on each and everything, but there would be some or their variation which is there. That is the common cause. And that's why I said it is not very easy to identify, and it is not very easy to eliminate. So that's a common cause which is always present. Now let's talk about special cause. What is a special cause variation? Special cause variation are the ones which are probably not there in your process always. It's a kind of variation which comes once in a blue moon, or if there's something happened which has never happened in the past. So therefore, it is not always present. It's an unexpected kind of a variation, and this cause is very easy to identify and very easy to eliminate. Okay? So we'll take certain examples to make you understand the difference between common cause and special cause. So let's take an example that if I'm going to office on a daily basis and it takes average, now I'm using the word average here, okay, 30 minutes to reach office, okay. Sometimes it will take 25 minutes, sometimes it will take 22 minutes, 23 minutes, sometimes it takes 34 minutes, 35, because this is the common cause. This can happen because of some factors like a normal traffic, something has happened, people are late, I woke up late, etc., etc. Someday I reach office after 2.5 hours. Okay, that is something which is a special cause, which is something out of the blue moon, which has never happened. So if that kind of a variation is there, or someday I reach within 5 minutes, okay, that is also not common. That is also special. So if that kind of a variation is there in the process, then we would call it as a special cause. And special cause variation are very, very dangerous if it is not addressed properly, if it is not looked upon, because that can probably destroy the process performance, that can destroy the variation in the process. And with the help of that, we will not be able to forecast or predict what's going to happen next. So therefore, it is very, very important. Without doing anything, it is very, very important to first identify that what is that special cause and eliminate it. Okay. If we don't address it that point in time, or probably if we delay it to some extent that we will do it after a week's time, then the problem will get more bigger and severe, and that's how we'll not be able to work on it. Okay. So that's why in a very layman terminology, I have talked about the common cause variation and the special cause variation. There is a statistical tool which is called control charts, which we will discuss, wherein we will literally show you that how to identify those spots, how to identify that whether this is a special cause or a normal cause, what is that threshold where we decide that it's a special cause or a common cause. Because I just shared an example now for reaching office that it is 30 minutes to 1 hour, 2 hours. But yes, basis the data behavior, there is a threshold which we will come to know when we do the control chart. But just for now, since we would have a long way to cover the control chart, but yes, this topic would be used multiple times in the DMAC training only. So that's how the common cause and the special cause plays a very, very important role. One thing which I want to tell you is that if the special cause is bad for the process, we say that we always kill it. Okay. So if I take an example of the sales, okay, the revenue for a given organization. If the average revenue for last 5 financial year is 100 million, okay, but the moment 1 year ended and the revenue drastically decreased to only 10 million, okay, that's a special cause. That is something which needs to be looked at that point in time. That's a bad special cause. But someday in one financial year, we reach to 1 billion. That is also a special cause. What do you think in that case we will do? I'm not sure whether I've discussed this point earlier or not, but what do you think in that case we should do?
In my opinion, Simar, if you have a special cause which is positive, we try to find out the reasons and replicate that to achieve that special cause as a normal.
Correct. So we just identify that and try and replicate or sustain with it so that we can continue reaping the rewards for the same.
Right. So the key message here is, and this is for everyone, even if it's a special cause or even if it's a good special cause or a bad special cause, we will not sit on it. Okay, we will try identify the reason and take necessary action. If the special cause is bad, we will kill it. If the special cause is good, as mentioned by Rahul, we will recreate it. Okay, we will try and see that whether we can convert that special cause into a normal cause. Probably we would see that what is the best that we can do. But if while identifying that that was a wrong data, that was a measurement error, then probably we would fix it and correct it. But in a nutshell, common cause and special causes are very, very easy to be very, very different to be looked at. So please pay your attention when you have these kind of variations. So let's proceed further. So this is an example which I've already shared with you. So I'll not take much time on it. You can go through in your presentation which I'll be sharing today. This is the same example which I've taken.